And welcome to Life After Computer Science, Day 2. Do you notice a new file on your desktop?
Yes.
Guess what we're going to do with it?
Exploit
All right, so go to your places. I have to do connect to server. This is weird. This is different. Go to your places. And in your files for, was anyone absent yesterday? Everybody was here yesterday? We got, okay. All right, so you were missing? You're absent? Yeah, okay, so we'll catch you up. All right, so go to your places, go to your files. Waiting on Sean's files. Everyone's in their files? All right, then make a folder called LACS, Life After Computer Science. You made a new folder?
Yes.
All right, in that folder, we're going to drag this file from the desktop. So this file is StdDraw, StdDraw. Just drag it to that folder, and there you go. Okay? Now, if you were not here yesterday, that's the only file you should have, yes? This is what you missed. We wrote this. There it is. This is what we wrote yesterday. Do you need a printout? Anyone else need a printout? All right, let's get this thing working.
I need to debug it.
Okay. File printy print. File printy print. So only one printout? Nobody else needs a printout? All right, Sean, there goes printer. They're all for you, Sean. On the printer there. Why did I kill it? What am I doing? Come back. All right, so now the problem yesterday wasn't the code. The problem was the jar file. Somehow it got corrupted when you copied it over. So what I did was I extracted this one file we were using in the jar file called StdDraw.java, and you can run it now very easily. Look, just go into your shell. Shell out.
Shell out,
Shush in. Oh God, this again. SCP all over the place. Okay, shush in with the -y. Don't forget the -y. Wait a minute, I gotta change this preferences. Yes. Jade, we need to talk. Come here. You never took this as a take-home test. I need this back as soon as possible.
Okay.
And you get this back.
Tomorrow as soon as possible, or
Well,
as soon
it
as
doesn't have to be
possible?
tomorrow, but soon. And you get this back. Okay.
That's it.
And that's it for now. Yep. All right, let me see. I want to make my background something more interesting. Maybe not that interesting. All right, how about that? Okay. And then, okay. Make this a little bit bigger.
Oh my God. Found it.
All right, there you go. All right, so don't forget to shush in with the -y, right? Okay, there you go.
Also important, don't forget that Java always wants things to be radians.
Is that what you did?
Yes, I've only changed its radians in one of the 20 days.
Ouch.
Now
Okay.
it's still going to work.
All right, so CD to your LACS folder, or I should say directory. And I have a bunch of junk here, but all you need is this. Ready? Java C, Polar.java. That's all you need. I'm not using the jar stuff, so you don't need this class path and all that. Come on, computer. And then run it. Bing, bing. And it's slow as all get out, but there you go. All right. All right. All right, so you should see something like that. Now, for some reason, my server is going nuts. So you're all running this at the same time or something? What's going on? All of a sudden, the server's about to melt. It's going completely insane. That's why my thing is way slower than it's supposed to be, by the way.
Oh no, mine's working fine, and I'm drawing.
Really? All right, anyway. So, there you go. Now, remember what we were doing? we were doing this. All right, we were graphing r equals sine 3 theta, and we got a 3-petaled rows. So who didn't get that? All right, so that's debug stuff today. So we know how to use standard draw, and we can do other stuff tomorrow. All right, what happened? Set one scale. Ah, interesting. Oh yeah, because it's this. Where's your file? There. It should be camel case, but it's not. I think that's all it is. Try it. Yeah, it's really slow today for some reason. Everyone's on the server graphing, you know. You see how laggy it is? Yeah, but there you go. Okay, good. All right, who didn't get a rose? Let's see the rows. It's running? Good. You're still typing? Okay. Yeah, it's laggy today because everyone's graphing at the same time, so. What? What are you trying to do? What?
No.
It's here?
Yeah.
Can I find... Well, you copied the file into here? Really? Where is it?
Oh, that file.
Yeah, that file. Yeah.
It's blocked.
Wait, what the hell is it doing there?
See? Okay. That makes
And
more
it's
sense.
slow because everyone's graphing. Wow, the server is really lagging because everyone's graphing at the same time. There you go. All right, so I extracted that file from the jar file, so you don't have to do the class path stuff, as long as that StdDraw.java is in the same directory or folder that you're working in. All right, let's see some graphs. I want to see some graphs. Where's yours? You still typing? Okay. All right. I should see some graphs. What?
1 and 2 both work fine.
But
Barely see the line difference.
Uh-huh.
It looks perfectly fine.
1 and 2. What do you mean?
Agrees at once.
Oh, okay. Right.
And that would free up.
Really? Because that. Yeah. Okay.
Free up your-
This is true. Yeah. Let's make everybody. What? 2 is okay? Really?
Yeah.
All right.
You can see that there are lines, but they are not far.
Okay. You are not knowing your password? Okay, let's see it running. Did you get it running yet? It requires typing stuff. Come on. Guys, you're being great on this stuff. When we're done with this file, we're going to print it. We're not done with this file yet. Whoa, what'd you do? Was this intentional? You don't know? Let's see. Yeah.
Maybe I can
Yeah.
look at a printout. Maybe I'll find an error.
That's strange. Well, it's not an error. Well, it's a semantic error. It's not a syntax error. That's odd. Wait, the Java seeded. All right, you don't need to do this anymore because I gave you the standard draw.jar, so .java. If that's there, you don't need to do that.
So why did that make this weird looking?
I don't know. Let's see what you get. Well, what is this? Well, it looks like it's doing one of the leaves. It's doing the leaf, but it's doing something else too. What the heck? Standard draw line from 0, 0 to x1, y1. This is x1, y1. This is 0, 0. 0, 0 starts at 0. Going from 0 to 316.1. Yeah, that's right. Math 2 radians. He's getting. It's in there.
Oh, that's what I did.
Yeah, what is- I
I
don't
had the
see it.
same thing.
Where is
It was
it?
an error over here last time I did that, but
From x0, y0 to x1, y1. That's right. Reset x0, y0. Start at 0, 0.
is theta the
Theta is.
I believe your error was that.
Oh, x1. Yeah, that'll mess you up. That'll mess you up.
Well, I was gonna save it for you, but okay.
Well, I did.
I can't do it one-handed.
And that's more normal, yes. Okay. All right, good. Ta-da! Yeah, you like the other one, huh? All right. Yeah, let's see it running. I want to see some pedals. If I don't see 3 pedals, you're not done.
I didn't run it.
You didn't run it? Okay, so go ahead.
Just put that in?
No, hey, we changed it. It's simply, where is it? Java C, space Polar.tester.java. Enter, yeah, and whoops, what happened? Are you in the right folder? CD LACS. You have LACS folder, right? Yeah. All right, do it again. Up arrow. Yep. And whoops, missing something on line 31 is what? What the heck? That's extra, yeah. Yeah, well, I don't know who did it then. The gremlins? What? Alrighty. All right, so Java it, and that should be it. Ta-da, that's it. Yeah, I think so. Good. All right, let's see 3 pedals. Come on. All right, now, if you don't like how slow it's going, remember you can fix that. How do you make it go faster? No, ludicrous speed. We don't have ludicrous speed here. Yeah, instead of 0.1, make it 1. Right, yeah. It would still look fine, so. All right, what if you wanted to change the color of the lines you're drawing?
Set color or set pen.
Set pen color, I think it is. Let's try that. All right, let's play around with this a little bit. All right, so
Wait, why not? Shouldn't there be an overwritten line?
it's set pen color,
I
yeah.
would override the the line command to give you the ability to change it, the color.
There's more than one way to skin a cat. Yes, of course. All right, before we start drawing, hang on, I'll be right there. Before we start drawing, yeah.
That's only a line per day, or both.
Okay. Before you start drawing anything, before the loop, right? Let's set the color to something else. What was it? Black, right? Let's make it, I don't know, red. So how about standard draw dot, yeah, but is it camel case? I forget now. Yeah, it's camel case. Set pen color, whoops, color, and it has several colors predefined. How about standard draw dot red? And to speed things up, I'm not going to do plus equals 0.01. Sorry, 0.1. I'm going to do just 1. How about that? Because it's really lagging everybody, all right? So can everyone change that? That's really lagging the server. When everyone does 0.1, just make it.
Also use 2. 2 will also.
2 is okay, or I'll do 2. All right, so that way we're only calculating 180 points.
Yeah.
And it's going to be red, right? Okay, save it. Try that. All right, so Java C it, and Java it,
Look at it. I mean,
and now it should be red and a little faster. There it goes.
perfect.
A lot faster.
That's that jump.
Well, it's way fast.
Yeah.
All right, so does everyone have red, fast, 3-pedal rows, and who's stuck? Because the server is actually making noises. It's like grinding. It's like I think it's the fan is grinding. What happened? Polar tester is public. Right, we decided we don't have to do all of that anymore because you copied that file here, right? You don't need to do all of this stuff. You can get rid of this here. It's very simple, just this. Hopefully that'll help. No, that's another error. All right, so what else did happen? Public class Polar tester is a capital T, isn't it? That'll mess you up. All right, save that, try that. That should do it. Or at least that's that error. And yeah, okay, so now do the Java thing. And you should see it. And there it goes. All right. Okay, so does everyone have, wake up, does everyone have red and fast? I need red and fast, everybody. You want to make it stand out a little bit more, make it like a thicker pen? You can set the pen thickness too. Let's see, set pen, oh, where is it? Set pen radius. All right, so let me do that. So if you're wondering what we did, we set the pen color to red before we started drawing anything. We set the step for T to just 2, not 0.1 to make it faster. But now I'm going to change this, the pen radius. Okay, ready? Standard draw dot set, let me see, is it camel case? Yes, because some of these are not camel case. It's weird. Like this, do you see this one? This isn't camel case, is it? That's sort of weird. Okay, set pen radius. I think it defaults to 0.002. So let's make it a little bit bigger. How about 0.02? 10 times thicker. That'll be 10 times thicker. 0.002 0.02 of an inch against is a pixel. So this will be wider than a pixel. All right, so did you see what we changed? We changed these 3 lines.
You graph two on top of each other.
Nice. All right, so do you see these 3 additions today? I made this 2, and I added these 2 lines here.
Oh, look, here it is in thick.
And thick. Wow. That's way thick.
I called it one.
Oh, 1, okay. You did 1 for the radius? Wow.
No, that's right, 0.1.
Boy, that's still big. Okay.
I did 0.1.
All right, so let's run it. Shell out. Where's my shell? Come on, shell.
Shell out, Tristan. Out of here.
Come on, shell. Okay. Java C it. We changed the code. Java it to run your little graph paper thingy. And there it goes, nice and quick. All right? So what, does everyone have a fast, thick, red polar graph?
I got it.
Wow. Oh, so you did with vertical symmetry and horizontal symmetry? Is that what you did? Oh, no, negative.
I just,
Yeah,
I
negative,
put in
yeah.
R, and then I used different color schemes. I think that's a cool symbol now.
All right, so you guys got it.
Now I want to put a yellow circle.
Yeah, that should be like the Olympics symbol or something, right?
What?
Okay, good. All right, let's make it red. Let's make it thick. Let's make it fast. Okay. Oh yeah, it's all. It's a final, so it's all uppercase. And it's beauteous. Okay, so you all got it. You all got it. Let's see. You all got it. Oh, it's thick and blue. Yay. Okay. And Patrick's got it. Let's see it. And you're still working on it. Okay. Got it. Good. Okay.
What do I put right here?
Let me put it up. Wake up. Why can't I get over here? Hello, wake up. It's not letting me get to the side here. Why is this stuck? Come on. Yeah, it's not lined up, damn it. Hang on. That's next. I'm going to talk about that. There is a circle command, but you can get that from this graph. You can get a circle. Let's see. Here's the code here. Does anyone need a printout? Anyone else? All right, so Jade. All right, so we have StdDraw.setPenColor standard.red and StdDraw.setPenRadius 0.02. And we changed this from 0.1 to a lot bigger, 2. Okay? All right, now, remember, if you put 3 here, you're going to get 3 petals. What if you put in 2? What if you put in 2 here? You're going to have 4 petals, right? Okay, let's save that. Let's see if that's true. So everyone has this now? You got it? Do you need a printout? Because I can't stay here.
Oh, that's awkward.
Anyone need a printout? All right, here's a printout just in case. All right, so let me run that. So Java C and Java. All right, so when you put the 2 there, you get 4 petals, yes? But look what happens when you put a 1 there. Let's see, where is it? Let's put a 1 there. By the way, I probably should have done arg's input for this. But anyway. All right, so what if you put a 1 there or just leave it out? You know, get rid of the 1 times. And look what you get. This is weird. Why isn't it a rose anymore? It's not a 4-petaled rose, it's not a 3-petaled rose. Let's see, 2 gives you 4, 3 gives you 3, 4 gives you 8, right? So 4 gives you 8, and 3 gives you 3, and 2 gives you 4. 1 should give you, well, 1. Yeah, I guess it's a 1-petaled rose. But why is it a circle? Because we have to explain this piece of code right here that we didn't explain yesterday. Why am I graphing r times cosine and r times sine? What is that about? Do you know how to convert from polar notation to Cartesian and back?
No, that had nothing to do with that. That was
That's something else, right? All right, let's talk about that. Come on. Why is this stuck? This thing's stuck on me today. Okay, go away. Go away. All right, so let's talk. All right, so when r is just sine, right? It's not sine of 2 theta, not sine of 3 theta, just sine of theta. Why do you get a circle? Yeah, this is not lined up good, is it? Wow, this is way not lined up. Look how not lined up this is. Ah. I can't because it takes forever. All right. So when r equals sine theta, we get a circle. See how nicely calibrated it is. Why do we get a circle? Because do you remember how you convert? Let's see. What if let's graph stuff. Okay. All right, so the idea is this. You can define a position with x and y. But you can also define a position uniquely with r and theta. So if you draw, see how nicely aligned this is? If you draw this point, x, y, right? It's also r theta. If this is theta, it can also be defined as r theta. But what's the relationship between, let's say, x, r, and theta? Do you see it? What's the relationship between x, r, and theta? My triangle's a little bit messed up, but there you go. X is this length here, and y is this length here, right? This is x, and this is y. So x, r, and theta, how are they related? I'll give you a hint. Sokotoa. It's cosine. Isn't the cosine of theta equal to what? Cosine of theta would be what? Adjacent over hypotenuse, x over r. Okay. What's the sine of theta? Do the same thing. What's the sine from this angle? Y over r. Okay. So what if I say sine theta, instead of writing sine theta, I write y over r? Dang it. Right? Now, cross multiply. What do you get? R squared equals y. But what is r squared? What's the relationship between x, y, and r? X squared plus y squared equals r squared? Isn't r squared equal to x squared plus y squared? Right? In other words, these are the conversion formulas. If I want to get x, I do r times cosine. Wasn't that what I was graphing for x? If I want to get y, I do r times sine. Wasn't that what I was graphing for y1 and x1, right? And r squared is x squared plus y squared. So, look. Do you know how to graph that? X squared plus y squared equals y? You can graph anything, huh? How do you graph that?
I don't even know what you're talking about. Wow.
How do you graph x squared plus y squared equals y? Nobody knows? I'll give you a hint. Didn't we graph it? We graphed this and we got a what? Right? Remember when there was a 2 in front of the theta, we had 4 petals. When there was a 3 in front of the theta, we had 3 petals. But we have a 1 in front of the theta, we had a circle. Could you convert this to the standard form of a circle?
Wait, isn't it x squared plus y squared?
Equals r squared, right. So that's not quite standard form.
So why are
Can you get it in this form? Do you know this form of a circle?
yeah.
Right? You know this, right? Can you get this into this form and figure out HK? Sorry, that's a K. Not a K. Pretend that's a K, okay? All right. So HK is the center of the circle and R is the radius. Can you convert this into this form and figure out the center of your circle and the radius? How do you do that?
Should it be 0, 0?
But it's not. Look at did you do the graph with theta equals 1? The center of your screen, remember, our x min was -1, our x max was +1. Our y min was -1, and our y max was +1. So the center of the screen is 0, 0. the circle wasn't centered in the center of the screen, was it? It was like up here. So the center isn't 0, 0. Can we figure out what it is? I did. I made this a perfect square trinomial so I could factor it. There it is. Do you not know how to complete the square? If you FOIL this, you get this, right? If you FOIL this, you get this. But the problem is, that wasn't in the original equation. So if I replace this with this, if I replace this with this, I've added 1/4 to one side of the equation. I better add it to both sides. All right, so what's the center? What's h?
0, 1/2, and the radius.
K, 0, right? We're comparing this to x minus h, so h has got to be 0. There's nothing here. Plus y minus k, so k is positive 1/2, right? Equals r squared. What am I squaring if I want 1/4? If I square it and I get 1/4, it was 1/2.
Here's the question.
Well, let me not write it that way.
Okay, I'm looking at it on the screen right now. We set our y max to 1, right?
Y max was 1, y min was -1, and the circle was like up here.
So the center of the circle is at 1/2, and the radius is at 1/2. Shouldn't the top part hit the top of the screen?
It's damn close.
But it doesn't.
It doesn't? It should. Well, the frame might be a little bit off, but it should be, yeah. All right, so it's the center of this circle is at 0, 1/2. It's right, in other words, up on the y-axis. And the radius is also 1/2, right? So if this is 0, 0, and this is 0, 1/2, and the radius is 1/2, it goes through 0, 0, it goes through 0, 1, right? Do you see it? That's why we got the graph that we got. Look. Let's see. Let's get back into here. Let's do this. I think I had it with the 1 in there already. Well, yeah, the top of the screen maybe is a little bit off, but it's going from -1 to 1 for y and -1 to 1 for x, and that's the center. This is 0, 0. The center is at 0, 1/2, and the radius is 1/2.
This code is wrong.
Yeah, well, the graph window is a little bit off, but that's the general idea.
I was
Now,
looking at it and I was going to guess that, and then I looked and said, oh, it's not, it can't be that, it's up the top.
do you know any other polar graphs? What if I change this up? How about 1 plus? Do you know what that's going to look like?
Is that the cardioid?
It's one of the cardioids. There are 3 of them. All right, so I'm changing this. So I'm just keeping theta in here. I'm not going to do times 2, times 3, times 1, anything, just theta. And 1 plus the sine of theta. Let's see what that looks like. Well, now the delta t of 2 is too big. Look at that. That's crap. Yeah. Yeah, I don't like that. Now look, it's supposed to be a cardioid. It's supposed to be sort of a heart shape. It got a little bit messed up
I
here.
don't think that's your problem. I think
Oh yeah, the initial zero, the initial position is wrong.
value is wrong.
Yeah. Okay, hang on.
I had to fix that when I was
Yeah.
trying to
Did you
find
do that one? All right. If you plug in t is 0, then theta is 0. What's the sine of 0? 0, right? Plus 1 is 1. So you have 1 times the cosine of 0 and 1 times the sine of 0. So 1, 0. It starts at 1, 0. So I got to change this. Bing. All right, and I think this is probably, well, all right, let's save it like that. Now, there are 3 kinds of cardioids. There's a limacon, there's a cardioid.
Lemniscate.
No, lemniscate is something else. It's a figure 8.
Oh.
Yeah. There's a cardioid that looks like a heart shape.
He told us.
There's a limacon which sort of has a loop inside.
Oh yeah, I like that one.
And there's a dimpled cardioid that doesn't quite come to a sharp corner for the heart shape, you know?
Oh yeah.
So let's see which one this is.
The heart's the one that's 1/2.
Well, let's see. Java C and Java. Yeah, my window isn't big enough. Remember, my window is going from -1 to 1 for x, and -1 to 1 for y. So I got, yeah, and it's starting at 0, 1. The initial position was 0, 1. I guess it's out here somewhere. So, yeah, I got to make my window bigger. All right, let's go do that. How do you make the window bigger?
Alt-tab and then change the bounds.
No, no, no. The actual physical coordinates that I'm graphing.
Go to 2 and 2.
Yeah, right here, right. So change your x scale, y scale. So how about we make this 2 to 2, -2 to 2, and -2 to 2 over here, and see what we get.
Your Y min will be too low.
Really? All right, so let's try that.
Well, think about it. We made our Y min even lower, and we already were off the chart for it.
Yeah.
But
Well, good
it'll
enough.
give you what you
There you
want.
go.
It's better to have
Okay.
it too big.
So there's a cardioid. Now, there are 3 different kinds of cardioids. There's a cardioid with an inner loop. It actually goes in. It has a special name called limicon. And there's a cardioid that doesn't quite come to a sharp corner. Do you know the graph? Do you know the equation of those graphs?
I don't remember which one's which, but if you make the sign, make the
Well,
numbers really big,
these are the 3 different kinds. Here I have 1 plus sine plus 1 sine. What if I made it 1/2 plus 1 sine? Let's see what that is. So before I had, if I call this number A, and the number in front of the sign B, A and B were equal. Now A is smaller than B, right? That's what I'm trying to say here. All right, let's see what we get. My initial position is wrong, but you get the inner loop, right? Why is my initial position wrong? Wait, hang on.
And here's the cool part.
My initial position is wrong
That
because
value out in front, that A,
Mhm.
smaller and smaller, as it approaches 0, the shape approaches a circle.
yeah. All right, so I messed up the initial position. If I plug in 0 for theta,
Just ignore the initial position.
I get 0.5 for r, and I have 0.5 times 1 and 0.5 times 0, so this is 0.5.
Yeah, you're going to have to change it every graph.
Yeah, I'm going to have to change that
Just leave it alone.
because this was really set up for the rows, but whatever. All right. And is that better? Yeah, that's better. All right, so there's a cardioid with an inner loop, also known as a limicon. And what if I change it up again, and I make it so that the number in front of the sign is bigger? Sorry, the number in front of the sign is smaller.
It'll get different.
So if I put this back to 1, but I make this 1/2 times the sign, then I get the dimpled one, right? All right, let's see. It said my initial position might be wrong. I didn't check that. And the initial position is wrong, but you get what's called a dimpled cardioid. It tries to get, see, it's not quite circular here. It's trying to come into the sharp corner for the cardioid, the heart shape, but it doesn't quite make it. It comes back out, and my initial position is wrong again. All right, let's fix that. If I plug in 0 now, I get 1 for r, so this is 1 again. So here's your dimpled cardioid. There you go. And that's the idea. So it's not quite a circle, but you get the idea. You can make it more crazy, like more pronounced, in other words. What if I made this really small, like 0.1? It'd probably be more pronounced. Oh, no, it's actually almost a circle already.
Yeah.
Yeah.
If you keep dropping it,
Yeah, it becomes more of a circle. How do you make it more dimpled?
and because we have a big pen size, make it closer.
It's got to be closer to 1. Yeah, okay.
Make it 0.9.
Yeah, okay. So that won't change the initial position.
You hit 0.9 now. See what happens.
You go closer to the 1, yeah,
Mine, I'm saving the way it is because I made a pretty picture and a screenshot of it.
of course.
You know me.
That's of course.
I
And is this a more pronounced dimple? Yeah, there it goes. It is pretty sharp, actually. All right, so you get the idea. So tomorrow we're going to use StdDraw to do an animation.
Ooh, that's
All right, there you go. So save all your stuff. We're done for today.
that's cool. Oh, and if anyone wants to see my pretty picture,
You could combine a whole bunch of polar graphs, make all kinds of crazy stuff. Yeah.
What I get. I just
Yeah.
get circled in the
All right. Bye bye YouTube.